Good afternoon, Twitch. Welcome back. We have another breakout session for you today. I'm joined here by my special guests and friends, Helen, Nuzette, and Nick. Please introduce yourselves.
Hey everyone, my name is Helen Lin. I'm a senior product manager here at AWS.
My name is Nuzette Atay. I'm an applied scientist in the CloudWatch organization.
And this is my third time on the desk today, so if you haven't remembered it by now, third time's hopefully the charm. I'm Nick Walsh. I am a technical evangelist on the team here, and I work side by side with Robert a lot of the time.
Okay, so for this session, I want to kick it off with a very quick story. For those of you who don't know, I used to be a software engineer at Facebook, and when I was at Facebook, and when I was on call, I would be looking at some of these logs, and they'd have all of these traffic patterns for our different services. And oftentimes, it was difficult to filter out the signal from the noise, to know what I should actually be paying attention to versus what was just kind of normal day-to-day activity. And as I understand it, you're going to walk us through an announcement and a feature that deals with that exact problem. Is that right?
Yep. Yeah, exactly. So we're super excited to be live streaming here from New York City today, announcing a new feature that's part of Amazon CloudWatch based off of machine learning called Anomaly detection, being offered in preview mode. Now, for those of you who aren't familiar with CloudWatch, it's a monitoring and observability service that our customers use to gain insight into the performance and health of the AWS resources and applications. Now, as part of a monitoring service, our customers can leverage and have multiple tools to collect the metrics and the log data that they need to monitor using dashboards. They can create alarms to notify them of operational issues, leverage CloudWatch events to take automated actions to remediate issues, and use logs insights to query and search log data at scale when they want to understand more. Now, one of the things that our customers often ask us is, how do I even know what the right alarm threshold to set is, right? So how do I know what normal versus abnormal is? And in reality, applications are dynamic by nature, right? So they're oftentimes a reflection of their end customers' usage patterns. And so with CloudWatch Anomaly detection, what we wanted to do was we wanted to build a new feature that's part of our overall observability toolkit that our customers, who are the IT developers, systems engineers, app developers, can leverage to help them create alarms that self-adjust based off of these dynamic usage patterns, and also leverage machine learning to help them quickly isolate and identify when anomalous issues occur.
That sounds great. Is there a demo that we can look at by any chance?
Yeah, we will have a demo that will show up later.
Okay.
We'll get to that. So,
yeah.
okay, so let's start off with the problems Rob explained, which is like, hey, there's lots of data that we need to watch and reason about, and that can be very difficult. And now we have this really amazing feature for anomaly detection. Maybe before we jump into what that looks like, could you talk a little bit about how SRE or managing these metrics works in the status quo, right? Like, what are the real ways that people are doing this out in the wild, and how will this automation help them?
Yeah, it's a great question. So, CloudWatch built this service. As a monitoring service, we monitor and collect a huge amount of data, somewhere in the ballpark of 1 quadrillion data points per month as of last October. This is a lot of data to watch after, but it's part of what our customers spend their time on day-to-day monitoring. So as they're doing this, one efficient way where they can better monitor all this data is to create alarms on key metrics that they have. But as they're creating these alarms, again, back to the idea is there a more intelligent or automated way where I can know what the appropriate alarm threshold is? And you know what? Applications change all the time. 75% CPU utilization during the daytime may be completely normal, but maybe my steady state at night is more closely around 30% or so.
Yeah, so this is really interesting that you bring this up, right? So it seems like in the status quo, lots of customers may set thresholds, right?
Yeah.
Based on their understanding of their data, they say, okay, this is an upper bound limit that may be normal, and this is a lower bound.
Yeah.
But we understand that there are inherently trends in data that will break that, and people don't like getting notifications that they know are not meaningful, right?
Yeah.
And so this is a nice middle ground of being able to have those manual thresholds, but also automate the detection of this in such a way that it is providing more meaningful insights and notifications for the user.
You got it.
Awesome. So with that being said, I know there's lots of different types of metrics that CloudWatch tracks, but maybe you could walk us through some of the patterns that exist in the wild that anomaly detection can now help with and help users manage.
Yeah, perfect. And I'll show you with some content here where you can see the pattern. So, generally speaking, what the algorithm is looking for is repeatable patterns that it can leverage to learn and train on to create and predict what normal behavior is. Specifically speaking, we've seen anomaly detection particularly useful in 3 common scenarios. One of them is what you see here, which is being able to detect unexpected spikes or dips in your metric pattern, right? So a lot of times, maybe you're monitoring your load balancer metric, and you get a sudden spike in your request latency, or maybe you're monitoring your database IOPS, and there's a sudden drop in your read and write operations. You want to get alerted for any time those things occur. Now, what CloudWatch Anomaly Detection will do is it will actually learn an upper and lower bound of normal behavior. And as you can see here, that spike that is in the graph, CloudWatch Anomaly Detection will automatically send you an alarm when this occurs, so then you can go and address the issue. Now
And so just to give a little more color to this image, this diagram that we're looking at right here. So this looks like a relatively steady state workflow.
Correct.
And here we have the line is the real-time value for the, in this case, CPU utilization. And so these, this shaded area is the upper and lower bounds that anomaly detection is automatically detecting.
Yep.
Right. And so, you know, we could reason about a steady state workflow and say, okay, I will set an upper bound at 0.576 and a lower at 0.271, but maybe there are other use cases where it's not as clear, right?
Yeah, absolutely. So another second one that we see a lot is, going back to the idea that applications are dynamic by nature. So, I may be operating a content streaming service, and weeknights are where I get 2x the traffic that I would get during weekday hours. And more so than that, on weekends, I might get 5x the traffic, right? So you have all these varieties in terms of what's normal behavior. How do you then choose what the right threshold is? And so with CloudWatch Anomaly Detection, you don't even need to set those thresholds. What it will do is it will actually learn those metric patterns, and it'll know that Monday through Friday, normal is 1x, weeknights it's 2x, and then weekends the traffic is 5x. And so as you can see, it will actually create a normal pattern based off of these normal points at that particular point in time, and self-adjust the alarm thresholds as it detects these pattern changes. And so you really only get alerted when your metric or your application is behaving anonymously compared to what it should be at that point in time.
Awesome. And
Yeah.
With the previous slide and this slide, we've seen 2 of the metrics that you're measuring, CPU and consumed write capacity units. What are some of the other metrics, some of the KPIs that we can watch with this system?
Yeah, it's a great question. So things like load balancer metrics, user connections, request count, memory utilization, and actually Nuzet will show a couple of those in his demo as well. There's actually one more use case where this is particularly good for, and the last one is very common here at what we see a lot in AWS. So when we deploy a service day 0 versus day 30, our expected traffic naturally grows, right? When we launch a service, we want our users to adopt it. We want our traffic to go up. And so a lot of times, we will, day 0, try and create what we think is the best upper threshold. However, day 30, day 60, I'm hoping that the traffic increases by 5x, maybe 10x. And so now I could easily exceed the upper threshold in terms of request count that I may have set up initially because I wanted to monitor DDoS attacks. Now, with CloudWatch Anomaly Detection, what it will do is it will naturally learn those traffic pattern growths and automatically readjust the alarm threshold so that 6 months from now, I don't have to come back in and remember to go back in and change my alarm threshold.
So takeaway is if I'm writing a DDoS program, gradually ramp that traffic up over 6 months.
It's like the boiling frog theory, right? It's like if you just raise the heat really slowly.
Hey, I mean, if my targets are getting more sophisticated, I got to keep up, right?
Well,
no, but what also jumps out to me here is that we see on the x-axis we have data points with repeated dates, and so what this shows me is that you can actually feed in multiple points of data over the course of a day, right? You have a pretty granular resolution with respect to how small these trends can be that we can detect.
Yep, absolutely.
That leads me to another question. I mean, how sensitive is this model that we're using here? How quickly does it react to these changes, both on the side of kind of detecting false positives and false negatives? Can you talk a little bit about that?
Yeah, it's a really great question. So, when the user enables anomaly detection, either via a single click on the console or programmatically via APIs, we go in and we train the metric data for 2 weeks. Now, what happens is once we generate the machine learning model, it constantly learns the latest metric data and constantly updates itself. So you enable it once, and you don't need to come back in, sort of like retrain or refutz with the model itself. Every data point that comes in, it will use that to then create what normal patterns look like.
That's very cool.
All right, I'm excited about all of this, but I, more than anything, just want to see it in action. So do you think that would be possible?
Perfect.
Sure.
Wonderful.
So let me show you how we can use CloudWatch Anomaly Detection. So in order to do that, I first log into my console. Yep.
And we are here in the default CloudWatch console,
This is
right?
CloudWatch console.
Okay.
So I can choose which metrics to use to enable. I can use through the alarms console or the metrics console. But today I'm going to show it through the metrics console. So in the metrics console, I have a bunch of metrics, and I can enable anomaly detection on any type of metrics. But as Helen mentioned, the ones that are most beneficial are the ones that have repeatable patterns, the ones that the machine learning algorithm can look at the history of the metric and understand patterns and trends. Some examples are CPU utilization, DynamoDB metrics, and I'm going to show it through a DynamoDB metric today. So I have this service, and in this service, I have a job that runs periodically and writes some items into DynamoDB. And whenever this job runs successfully, I have these spikes in my graph. So if the job is successful, I will have these spikes. But if the job fails, it's going to be flat. Or if the job is successful in some way, but it doesn't write all the necessary items, I will have a lower peak. And I want to catch these cases because if this happens, my system is having a problem. And enabling anomaly detection is very easy. All you need to do is come here. There's this button that says enables anomaly detection for this metric and statistics. So the moment I click this button, the training is already done. The machine learning algorithm is actually very fast. It analyzes all the items, all the metric data. And from now on, it's going to start generating expected normal operating band. So with new metrics, all of these new metric values will come with a normal band. But it's going to take a while for it to trickle down. So instead of waiting for it, I want to show it what these bands look like on a metric that I enabled before. So this is an elastic load balancer metric. And it measures consumed units, which is a proxy for your customer traffic. As you can see, there are some daily patterns, like during the day, it picks up, at night, it is slow. This is weekend, lower traffic. And the machine learning algorithm that we use at CloudWatch, anomaly detection, knows these patterns and creates a normal band accordingly. Let's take Monday, for example. Monday traffic is different from any other day's traffic. So it creates a normal band to fit those patterns. So on any given Monday, if it doesn't look like a typical Monday, because maybe there's a problem in your system and the customers cannot access your service, you'll be notified. Or maybe your system was growing. Week over week, there's an upward trend, but the trend is not there anymore. CloudWatch anomaly detection is very useful for catching these cases.
So this is really powerful for two big reasons, right? The first is that we know those trends about our data from observing it and watching it for a while, but we didn't need to specify any of that, right?
Exactly.
We didn't say, hey, we know that the first day of every week, it's going to be a nice big peak, right?
Exactly.
We didn't specify that. But then B, each of these trends of varying frequencies, essentially, can be automatically sussed out. You know, this is not a matter of finding what the one consistent trend is.
Correct.
The anomaly detection will essentially separate the different frequencies of trends and still be able to create those bands intelligently based on it.
Correct.
Wonderful.
So once I have this metric, I can add it to my dashboard. And as a service owner, I use these dashboards a lot because I want to monitor what the health of my service is like. So I have a bunch of metrics here. And as the number of metrics go up, it becomes harder to decide what is normal for that metric. They all have some values, but if I have tens of metrics, it's real hard. With this anomaly detection, you can clearly see what these bands, what the normal bands are. And if something is abnormal, maybe my system is having a problem, I can easily detect that there's a red spike here, which I should go and investigate. And I can have all of my metrics in this dashboard with the anomaly detection on, so monitoring is very easy. But maybe even more importantly, as a service owner, if something is wrong in my system, I want to be notified immediately. So I don't want to wait to go and check this dashboard. And for that, I can use anomaly detection alarms. So I can go to my metrics console. I have these bands, and there is this button here that says create alarm. Once I click on it, it takes me to the alarms console. Here I see the normal bands. I see my metric values. And there's this option that says anomaly detection. So once I choose this option, I have three options underneath, outside of the band, which is the most common case. If something is wrong, just tell me. But there are two other options, lower the band, greater than the band. And because there are some metrics and cases where you don't want to get alarms on both ways. For example, latency. You want to get notification if it goes up, but if it goes down, it's not necessarily a bad thing. You don't want to get an alarm on that,
Maybe
right?
you just want to be notified to see how performant and efficient your application is. Joking, but yeah, obviously there are some values that you only want to know if they supersede or
Yes,
are
it's a
under
very
accepted
common
values.
case. And the next button, next box is the width of the normal band. So the default is 2, and this is again the most common use case for all of our customers. But you can change the width. So you can do 1. So you will get more sensitive. Alarms will be more sensitive because the bands are much tighter. Or you can have, let's say, 10. And you
Great.
can see how it works here.
Wow, yeah, this was actually one of the questions I was going to ask eventually. Like, where is the knob that the customer can tune with respect
Exactly.
to how
Exactly.
confident they are in the stability of their workflow with respect to the bands? And so
Exactly.
this is essentially the knob or the dial, right?
Yes.
You get any integer, and increasing it will increase the range of the bands.
Yes, basically this integer is the multiplier of the standard deviation. So
Okay.
if your metric is very noisy, you will have a wider band, but you can also adjust this multiplier of the standard deviation using this metric to adjust the width. So I have my band, -4 is not a good number. I click next. I choose a topic. Let's call this alarm a name, let's say DynamoDB, write operation, health. And everything looks good. I have my alarm enabled. So going forward, whenever the metric value is outside of the normal band, I'm going to get a notification. And I can also add this alarm to my dashboard so that I have all of my monitoring tools in one place. And I can see the normal bands. I can see the state of my alarms. Clearly, this alarm is in OK state. Everything is great. This is a great tool for monitoring. And that's all I want to show today. We believe the machine learning technology behind CloudWatch anomaly detection is going to make monitoring easier. And it's going to help our customers and system owners to take unexpected changes in their systems faster and more accurately.
Definitely. I mean, we clearly walked through the process by which we can set the alarm to automate that once an anomaly is detected to be able to trigger that.
Yeah.
But I think one thing, for example, if you're onboarding someone and they may not be intimately familiar with your data set and the trends,
Yeah.
they actually, through the bands that are created here, have an idea of like, oh, this value might be approaching something that's bad, or this is what they can expect.
Exactly.
Which I think provides a lot of valuable insight into the day-to-day operations of your data, not just in remediation.
Yeah,
Correct.
that's true.
Awesome. We had one question from the chat. I'm not sure if this is specific to your team or not, but the question was, can users expect an Xray API integration with CloudFormation alarms? Or was that CloudFormation? I guess CloudWatch alarms?
Sorry, Xray integration. with
Xray
CloudWatch
API
alarm.
integration with CloudWatch alarms.
Yeah. So the anomaly detection service has APIs that when you get an alarm notification, you can take it to a downstream application, such as third-party tools or whatever tool you want to use to remediate. Xray also has a set of APIs, but today, the way that the service is built is Xray APIs are specific to enabling tracing and data like that, and then CloudWatch APIs for anomaly detection are specific for enabling anomaly detection.
Great. So I think maybe to bridge that gap in our last few seconds here, if customers were to take that trace data from Xray and use that as its own data source, then they could set a CloudWatch alarm on whatever that third intermediate data source would be.
If they ingest it as a metric, then we can apply anomaly detection on it. Yep.
We have another question in Twitch chat.
Yeah.
Mana Kanapa says, does it have CloudFormation support?
That's a really great question, and Nuzet and I were prepared for that. So we actually will have CloudFormation support shortly. It is not available today, but in a couple of weeks it should be available, and we will make an announcement once that is available.
Very nice.
Yeah.
I think that brings us to the end of our time here. Are there any parting thoughts you'd like to share, or maybe you could tell us a little bit about the future and what's next for anomaly detection?
Yeah, I've got a couple thoughts. feel free, the feature is available in preview. We love customer feedback because it really helps us tune and improve the algorithm, and really just, this is how we build our cloud service, right? We prioritize the base of our customer feedback. This is a initial release. We're going to continue to improve the algorithm over time. To get started, visit the CloudWatch homepage. And you know what? I'm actually super excited to be here in New York, and you know why? Because I have a slight obsession with pizza, and I love the fact that I can get a slice of pizza at 1 o'clock in the morning, and there's absolutely no shame involved with that.
Yeah, there's no shame. You do that.
All right, well, awesome. I think that's going to about do it for us here on the Launchpad desk, but tune in. I think we have at least one more session here to close out the day. So thank you again, and stay tuned.
Thanks, guys.